Hey everyone, continuing with our graph and transformation, we actually hit the last type of graph we need to know how to sketch, the derivative graph. And actually this is supposedly also the last part of our differentiation chapter, but because when you're talking about derivative graphs, it's more of graph sketching, so I move it to graph and transformation. Alright, but the idea still draws from differentiation, where f prime is the first derivative, it is the change, instantaneous change, or instantaneous rate of change, hence the gradient. Alright, so we have to apply what we know about our gradients to our graph sketching as well. So if y equals to fx, and we have minimum point at b and maximum point at a, and they also told you that at x equals to 0, dy dx is minus 3. Alright, fantastic. How do we draw the graph? Well, first section the graph, like how we always use to, basically splitting based on the vertical asymptotes. So in this case, we start with the left side first of the x equals to minus 1 asymptote. So what I do is, first you have the minimum point at minus 2, 0, which means that the gradient at this particular minimum point, as we know, is 0 at x equals to minus 2. So let's name it down here. Immediately have minimum point, so minus 2, 0. Of course, you cannot choose not to label the point so early because you may not know the graph, but if we already know the nature of a minimum point, the gradients before is negative, the gradient after is positive, right, from your first derivative test, if you recall, right? Therefore, actually, the values before your minimum point would be below the y-axis for their gradients. Okay, so let's take a look what happened. So, well, let's calculate before the minimum point. So we know that the gradient starts from 0. And you notice that the gradient is negative, so you get negative gradient. But what do you notice? As x approaches negative infinity, y approaches 1. What does it tell for our gradient at negative infinity? It is essentially close to 0, right? Because your values get very close to 1, the gradient will get very close to the gradient of y equals to 1. Therefore, the gradient gets very close to y equals to 0, and we have a horizontal asymptote at y equals to 0. Now, how do we start? The gradient gets 0 and then goes close to 0, but you notice right down here, if I were to just sketch the graph more accurately, this is 0 at dy dx equals 0. You notice that your graph starts off at 0 and then it goes up and then away, right? It sounds like a Z shape. So how does that help us? At this point it's negative. At this point it's negative, right? All of them are negative. But if you look at the change of the gradient, right, this part is steep, then it gets less steep. So you know that you start with less steep, so something like this. Your gradient starts off with a very small value, and then it hits a maximum at around this point, right? Then it gets more steep and then like this. Okay, so it gets less steep, more steep, less steep again. If you notice this is very close to 0, then ooh, large gradient, then okay, calm down, and then back to less steep again. Right, so less steep, more steep, and less steep. Of course, you wouldn't get actual values, but this is the shape that you should draw. Okay, so that is the first part. Now, let me make some space. Alright, now what happens afterwards? Okay, if you look at the graph afterwards, you notice that it starts from 0 and it shoots all the way to infinity. How do I know it's infinity? Because it is basically following the vertical line at x equals to minus 1. Alright, so your graph simply starts from 0 to infinity. But how does the graph change? How does the derivative change? You notice that your graph is at this region is increasing at an increasing rate. Because it is increasing at an increasing rate, your gradient must be increasing at every point as well. As such, your gradient will be increasing. Until where though? Now, you have the vertical asymptote at x equals to minus 1, which means that there is no point at x equals to minus 1. Therefore, there's no gradient at x equals to minus 1. So we can immediately draw the vertical asymptote at x equals to minus 1, and likewise x equals to 1, right? Okay, so using that idea, your gradient will actually follow something like this as well, just increasing at an increasing rate. Of course, you should try this to make this more smooth. I'll try my best here. Okay, something like that. Now we move on to the middle portion, and again we have the maximum point at minus half 0, minus half minus 3, therefore we have minus half 0 as our maximum point. And again, if you know that the nature of maximum points, well, what happens before have a positive gradient, and what happens afterwards have a positive gradient based on this first derivative test. So we expect your gradient to be positive on the first part. Once again, your gradient starts from positive infinity. I know this is in a negative region, but if you look at the gradient, it is positive, alright? So don't get confused, and ends with 0 at the maximum point. And now instead of increasing at a decreasing rate, the gradient is now decreasing, right? It gets positive and then not so and less positive until 0. So your gradient is increasing at a decreasing rate. So your graph will look like this. Starting from positive infinity, it will then go down here. Thereafter, what happened? Now your graph afterwards goes from 0 to negative infinity, right? Because your gradient starts from 0 and is now negative, and it shoots all the way down to x equals to 1, following the vertical line, and it's towards negative infinity. As such, it is now also decreasing at an increasing rate. So it's decreasing at an increasing rate, which means that your gradient is getting more and more negative. So your gradient will look like this. Right, so it looks like kind of like a cubic graph. And you tend towards, I'm not gonna be cautious anymore, just whatever. Something like this, alright? And we know that at x equals 0, the derivative is minus 3. So we have 0, minus 3 as well. Right, so this also tends towards it. Negative infinity towards x equals to 1. Now we're done with the two parts. Let's consider the last part, or the right side. The gradient is at this point is negative infinity because it's pointing downwards. Now what happens? And it tends towards y equals to 1, which means that it is 0. And what you notice is the value is also decreasing at a decreasing rate, right? That means your gradient is getting more and more positive, or aka less and less negative. So we look like this, and you'll tend towards 0 as well. Alright, so this will be the derivative graph of this particular graph right here. Obviously this part could be way better by making it more continuous. Yeah. Wow. Okay, so this is the derivative graph of f prime x. Alright, in the next example, I'll try to get something with a oblique asymptote and show you the difference between oblique asymptote and a horizontal asymptote when it comes to derivative graphs.